I'm very happy today. It's Saturday morning, and even though it's raining outside, it doesn't really matter because we get to spend time with our Amigas. This thing here, this mess, is actually an Amiga. It's a regular A1200 with quite a few expansions because I'm making a build of it, which is a subject for a different video. Doesn't matter. What matters is that in the past several weeks I've learned a lot about the USB support in the Amigas. And that's what I'm planning to share with you today. Let me start with a disclaimer. This is by no means the only YouTube video on the subject of USB support in the Amigas. There have been plenty of them. Actually, one of the finest ones I've seen recently is by 10 Mark, 10-minute Amiga Retrocast, and I love his videos in general, they are very enjoyable. He approaches the subject from a bit different angle. He uses a rapid road instead of the spider card. He discusses different parts of the Poseidon software from what I'm planning to do. And also I wanted to delve a little bit more into the history of the USB support in the Amigas. And actually, let's start with that. Let's start with history. So the most important bit to remember is that the classic Amigas and the USB are two different eras. There was no overlap. So the classic Amigas, the line ended with the bankruptcy of Commodore in 1994, and no engineers, no designers behind the Amiga even knew the acronym of USB. That was before the USB. USB support or USB history started in 1996 when the standard was officially announced, but it wasn't really until 1998 when it started to become popular with the introduction of Windows 98, which supported USB natively. There was also iMac G3, which didn't have parallel or serial ports. That was a huge revolution. It only had USB ports, which again popularized the standard a lot. And that's where the history started. From then on, we had new iterations of USB. In 2000, we had USB 2.0. Now we are at USB 4.0. There are tons of connections, tons of ways of using the USB, and there's practically no computer device that wouldn't be supporting that standard. It's everywhere now. Again, that was not the case for the Amigas. Amigas were never meant to support USB. But, as we know, Amiga spirit never died. So there was a gap. There were Amigas, there was USB, but there was no connection. So people started creating add-ons that would provide this missing USB support in the Amiga. The first one that I'm aware of, and maybe you can correct me, maybe there was an earlier one, but the first one that I know of is Thylacine by an Australian company. That was created in 2001 or 2002. The original Thylacine is an extremely rare device these days. There are new iterations of them. The PCB design is available on the internet, so people are creating new versions or variants of Thylacine. Then there were devices by E3B, a German manufacturer. There were quite a few of them. There was Highway and Subway, there was Algor, there was Deneb. Deneb is again pretty rare these days. Later in 2014, Rapid Road was launched by individual computers. Then there was ZZ9000 by MNT, which does not fully support the Poseidon stack, as I understand, only some parts of USB stack. Then there's the exciting Warp series from CS Lab. Again, they don't support all USB functionality as far as I know, but this is all work in progress. And there's Freeway, which I've recently ordered from DJ Cook, and I can't wait for it to be delivered to me, and maybe I'll record a video on that separately. So there are quite a few devices to choose from. For this video, again, I'm going to use a Spider 2 USB card. It's a PCI card that plugs into the Mediator platform. I'll be talking about Mediator in a different video from the Amiga Sandwich series. And to wrap up the history part, where does the software support fit into this picture? So there are really two software stacks that matter in the Amiga USB world. One is Poseidon and the other one is Amigas. Poseidon is a bit older. Its development started in the early 2000s, and I think it ended 2014. Around that time, Chris Hodges stopped providing updates to Poseidon. But I may be wrong again here. If anyone knows better, please correct me. And then there is Amigas, which is a newer stack, very exciting because it seems to be less restricted license-wise, but it also seems less complete than Poseidon. I will revisit Amigas maybe a bit later because it's still in active development. As I understand, it doesn't support my Spider card, so I was unable to do that today, but definitely exciting piece of software I'm going to talk about. Today I'll use Poseidon. So Poseidon and Amigas are really the two things that matter in the software space. Now that we've had our history lesson, and still before going to the practical side of things, let's explain a little bit more about the technicalities behind the USB stack and the Amiga support for it. The USB stack can be imagined as a tree-like structure. I will represent that structure upside down with the root being on the top, but generally it all starts with the controller. So this is the controller. In our case, it's the Spider PCI card, and specifically it's the chip that is covered here by the Spider label. The chip is a NEC USB chip, and this specific controller includes already in it three hubs, one full speed and two high speed. There is a different. Full speed was the original USB 1.1 12 megabits per second specification. The high speed ones are 480 megabits, that's a USB 2.0 standard. So three hubs are already in it, and the three hubs included in the controller are called root hubs. There could be one, there could be two, there could be more. In a computer, you would have them built in on the motherboard in a modern computer. In Amiga, of course, they were not there. So the controller and the three hubs provide already connectivity for devices. So you can connect devices directly to the ports here, but you can also connect external hubs like this one here. This one has 10 USB sockets, and we will use it later in some of our exercises. And then to that hub, you can connect still another hub, which we're also going to do just to represent the hierarchy a little bit in practical terms and see how it's represented in the Amiga. But devices can also be connected at any level of that tree structure. So you can have one device connected here, multiple devices connected here. You can have multiple devices connected to another lower level hub. It's all possible, and it's very flexible, and each device has its own number and its own unique identifier, so they can be unambiguously identified within the whole USB subsystem. You need to remember that hubs also have numbered ports in them. So this one again has 10 ports, this one has this has 5 ports. The ports can be slower or faster. Now with USB 4.0 we have even faster ports, but that doesn't matter from the perspective of the Amiga. Amiga devices really support, from what I know, only the USB 2.0 speeds. It wouldn't make, I think, much sense to support anything faster because of the speed of the Amiga itself. Now, this whole tree is called the device chain in USB terms, and each of the devices connected to that chain can in turn have multiple interfaces, logical interfaces. And the best way I think to imagine it is if you connect an audio-video device to one of the hubs, and that device would have an audio interface plus video interface. Some of the devices have many more interfaces, some of them have only one. So there are all possible configurations that you can imagine there. And now this whole USB stack, logical and physical stack, has to be represented somehow in the Amiga. In this video we're going to use Poseidon software to show how that stack works. Software stack is a concept that is not specific to USB alone. The best known software stack is TCP/IP stack, which stack is basically any software that is composed of layers which are roughly more or less independent of one another and which interact with themselves at different levels of abstraction. The TCP/IP stack starts with the physical layer. Look at here, this is a networking card here with an Ethernet cable connected. So the Ethernet cable represents the physical layer of the technically called OSI stack, but it's just the TCP/IP stack. That's the physical layer, versus when you go to your computer and type something in a browser and look it up, that's the highest level, is the application and user level of the TCP/IP stack, the most abstracted one from the hardware, and versus the Ethernet, which is the most concrete one. It's very similar in the USB stack. There are layers that are closer to the physical communication, specifically individual bits of information sent via the USB cable, versus the abstracted layer, which is like events and transfers of files, these kinds of things which are closer to the user space. So the USB stack that I'm presenting here in this video is Poseidon by Chris Hodges. And it's very interesting, and it's a beautiful piece of software. Christopher Hodges wrote it in his when he was in his 20s, I think. Again, he stopped development 2014, which is disappointing, and I'm really hoping that he comes back to that. Generally, Poseidon is just as any USB stack, composed of layers. The most important ones are the Poseidon library itself, which manages the whole USB subsystem. Then there are classes of devices. The classes, those classes correspond to USB standard defined classes. They have their numbers, they have their names, and generally they represent a certain category of devices. Like imagine a pen drive would be the mass storage class, versus keyboard or a mouse would be HID, human interface device class. There would be audio video classes, all kinds of all types of devices that we can connect to our computer. So we have the as I mentioned, Poseidon library. We have the classes. Then we have the device drivers themselves, which are closer to the physical device, or individual or specific to a device, and which interact with Amiga, with the Amiga OS system. So an example would be the input device, which is an interface between the HID class on Poseidon side and the Amiga system. So it translates certain events that happen on the USB stack to events that happen within the Amiga OS, like clicks and moves of windows. Like if you move your mouse or click, that's what input device is responsible for. And it's also important to note that classes on Poseidon side can be attached either to individual interfaces of the device or to a device as a whole. An example of a class that is attached to a device as a whole is the ASICs Ethernet class, which supports multiple USB networking interfaces. And the two remaining layers of Poseidon software are the tools that come with it, the CLI tools, as well as the amazing Trident UI, which we're going to present in a minute, and the notification layer, which basically tells us as users and tells the OS about any events like connecting, disconnecting of a device and such. To add a little bit more complication on top of all of that, I need to add that there's this device concept, there is this interface, which could be multiple of them per device, but per each interface there are also endpoints. Endpoints are, you can imagine it as an API endpoint. If you're a programmer, there could be multiple endpoints for different functionalities, and that's what it is. So there could be an endpoint which accepts very short bursts of data, like imagine clicks of mice or moves of joystick, little tiny pieces of information which have to be accounted for, each of them. Then you can imagine bulk transfers of data, which would be a different endpoint. Those bulk transfers are perfect for any mass storage devices where you have to transfer a lot of data, and it all again has to be accounted for. And then you can imagine an endpoint which is even faster and even accepts even more data than the bulk endpoints, but on the cost of not necessarily sending all the data in a precisely and accurate manner. So not all data has to be accounted for, and that's perfect for all kinds of video streaming and audio streaming, where not every bit and byte of data has to be accounted for. So that's the additional complication. And one last complication is that each device can actually can actually support multiple configurations within it. So you could imagine a device which where you switch the functionality into something completely else, or a different variant of the present functionality. For example, a keyboard that switches layouts, and that is also supported by Poseidon. Chris Hodges, when I wrote his documentation, he actually said that he actually said that he's never seen a device that has more than one configuration. I think I have one, unless it's some kind of error on some kind of bad device. I'm gonna show it to you later. Now, I know that was a bit intense and super boring. Let's see what it all looks like in practice. So there is all that interesting hardware that started to pop up on the market from 2022 all the way until now, but which of those hardware add-ons are currently like the real practical option for a person that doesn't want to spend hundreds and hundreds of euros and rather to go for something reasonably priced? So I think the practical options are currently actually the Spider PCI card, for which however you need a mediator PCI bus board, which is good to have anyway, or Rapid Road from individual computers. Rapid Road is amazing, by the way. I've used it a lot. I've used it in my desktop Amigas and also in my A500 through AK 500 Plus card. There's also the new freeway interface, which again I can't wait to receive. It's already ordered. So there are a few options. Of course, you can also go for the extremely rare DNEP or Thylacine or other cards. All the options are in front of you, but I think again practically it's the Spider or Rapid Road or Freeway, I think. Also the USB interfaces in ZZ9000 and in Warp are there, but again they are not they don't provide full USB support as the Poseidon supported add-ons do. At this point, I think it's also worth mentioning about the dispute and the disagreement between the Lbox company, the manufacturer of Spider, and Christopher Hodges, who is the developer of Poseidon. They initially worked together, and Poseidon was delivered together with Lbox card initially in early 2020, in early 2000s. But then they split their ways. I don't want to speculate on the exact reasons why that happened. It was not for technical reasons, it was for legal, corporate, personal reasons. Usually in such situations, it's best to just stick to the material that was publicized. And what was publicized is that Lbox did something bad. Then Christopher Hodges reacted to that strongly, and then they split their ways, and Poseidon wasn't delivered with Lbox cards anymore. Lbox wasn't allowed to bundle it with Spider cards. So now, as of 2024, the situation is that you need to get your Spider card from Lbox separately. Get Poseidon from currently it's downloadable, legally downloadable from Rapid Road wiki page. So you get that separately. Then you take the spider.device file, just a single file, from Lbox. They can mail it to you if you have the serial number of your card, and you can provide them via email. They'll mail it to you, and you drop that spider.device into the devs USB devs folder of the Poseidon stack. So that's that, and it then works. But again, that it's pretty unpleasant that those disputes affect the Amiga community even until now. But that's the environment that we're operating in. Unfortunately, it's not the only example of this kind of politics. All right, having cleared that up, let's start connecting things, and let's start looking at how they are represented in the Trident interface, which is the UI for the Poseidon stack. Okay, we're starting from a bare bones controller, nothing connected to it except just one cable which controls my VGA to HDMI converter. I need it to be able to screen record for you, but that's the only one. Let's pretend it's not there, so I'm gonna show only the information about the controller itself and its built-in 3 root hubs. You remember the concept of the root hub. That's the main hub that governs everything else. So let's click into the Trident software. Trident is the UI that allows you to control the Poseidon software, but it's not really needed. You can do everything from the CLI. We'll show a couple of CLI tools in a moment, but let's start with Trident. So Trident welcomes you with a nice image of the Poseidon god himself, and he's holding the trident. That's where the names come from, and in the left hand side you can select multiple sections. The controller sections will show you the root hubs included within your controller, whatever controller you're using. Again, the name of the device assigned to that controller shows you that this is the Spider device. That's the single spider.device file that I mentioned we need to add to the Poseidon installation. By the way, installing Poseidon is extremely simple, so I didn't even bother recording that. You just click through, you agree to everything, it installs the main Poseidon .library in your libs drawer, and it adds a section in your startup sequence, adds the classes to specific folders, and installs the Trident UI as well. So these are the 3 hubs, the main hubs that we have here. One of them is In case of Spider, one of them is the slower one, the so-called full speed, 12 megabits per second. I think it corresponds to either the first port at the bottom or two first ports at the bottom. The remaining ports are high speed, which is 480 megabits per second. That's USB 2.0 already. So here they are functioning, they are online, they have their unit numbers. Now these are the units within the device. If we close that window and try and use the CLI tools, the three CLI tools I use most frequently are PSD dev, not PCD. PSD stands for Poseidon, PSD dev list. So if we just issue that command, it will give us a lot of information, but let's redirect it to a file. Okay, and now let's preview that file. And that is actually skipping the information about the roots, which we didn't want, because by default this command skips the information about root, but we want to actually show the roots, so we need to add an option. Is that show root or show roots? I think it's show root, that's fine. Much more, yeah, now the information about the root hubs is there. So there's tons of information, extremely interesting information if you want to know about USB and how it's represented in Poseidon stack. I'll just mention a few things, but very interesting ones, specifically from the perspective of what we've been talking about earlier about the hierarchical structure of the USB stack. So the information that we have here at the beginning is about one of the root hubs. So it's called this, it has this dev ID within Poseidon. It has its specific product name, which it shows to the Poseidon stack and to the Poseidon library and hub.class program. You can see who the vendor is, and you can see right away that the chip on the Spider card is the NEC Corporation. It has a certain state, so it declares its speed and it shows the configuration parts. Now, this is very important. The device address is 1. Each of the devices have a certain number assigned. I think it should be unique, even though I've seen somewhere when I connected many devices, one number was repeated, and it still bothers me because I believe it should be unique across the entire USB stack. But let's ignore that comment for a moment. So device address is 1. And it is at port 0 at root, so it's not connected to any other device. It's basically one of the root hubs. And if we scroll down, you see that's the second built-in or root hub. Again, device address 1 because it's all the same controller. And the third hub, this one is full speed, not high speed compared to the other one. So full speed, it means the slower one. High speed is the faster one. Again, device address 1, it's the same controller, it's the same device. And then I'm not going to go into the detail of it because it's a device connected here, and I want to start with different devices, but that's our VGA to HDMI converter. Also, a funny thing is below each device you will see a Google link that you can basically copy and paste and search about this specific device ID to find out more. For example, to find out whether there are specific drivers for the Amiga there. Okay, but this is just the controller, nothing connected to it. Let's start connecting, and we'll start by connecting an external hub here. Let's quit this. Let's see what Trident shows first. Now, you see the controllers remain the same. because the controller is only one in my system. There could be more, by the way, you can use multiple. But on the devices list, we see more hubs now than just 3. We actually see, so these are this hub, the first one, is the built-in root hub. The 2 last ones are also the built-in hubs, so 3 hubs in the controller. And now we have 3 new hubs, USB 2.0 hubs, which are assigned the hub class as well. All of them are running. You see also the designation of single TT versus multi TT. I think it has something to do with how the protocols are translated between the slower 12 megabit and faster 480 megabit USB, as far as I understand. But that does not really bother us at this point, because now what we have is we have 10 ports in this external hub plus 5 in this one, so total 15 hubs at this point, but I'll connect more. So let's now connect one more hub here, which is the built-in hub of this Dell monitor. It has a this Dell monitor is amazing, by the way. Thank you, Dorian 3D, for recommending it to me. It has a built-in hub, actually 2 hubs. You see, these are the ones, standard microsystem, Corp standard microsystem, both high speed, again, multi-TT, single TT, different ways of protocol translation. Now we have total of, I don't know how many ports, but we have 3, 6, 8 hubs, total 8 hubs in this single Amiga 1200. It's becoming pretty exciting, but that's not the end. There are devices which serve both purposes. One, the end device and USB device, and second, a USB hub. And this keyboard is a good example of that. So if I plug it in, and actually my hub here has a very nice functionality where you can switch on and off some of the ports, but let's switch just this single port on. So what you will see is that we obtained one more hub. It's Apple computer, because it's an Apple Apple keyboard, and it's running again, and it gives us 2 more ports here. Pretty amazing. So we now have 3 levels of hub hierarchy, and we can start connecting devices, and let's start by connecting some pen drives just to test the mass storage class and understand it a little bit better. There were many more pen drives at my home than I imagined. So I plugged them all in here, aligned them nicely. Remember, I'm using this external hub with switches per port, so I'll be able to switch them on and off as I please. But let's first look at the Trident UI again. Let's see the devices. So we have quite a few devices again with our, actually not devices, hubs plugged in, plus this single device for VGA to HDMI adapter. But there's also this one ghost spiritual, I don't know what it is, I need to research that. It shows up every now and then. It's a joke class, spiritual, it's a ghost device, also a little bit of a joke on the part of Chris Hodges, but I'll find out what it is. You can't see me, so I'm pretending I don't see it. So let's switch one of the pen drives on, a random one. There it is. It popped up immediately. It's called Store and Go. If I quit Trident, it's there. It's represented as an icon. So one of the things that I may advise you, because that's the mistake that I made, I was plugging the device in. It showed on the devices here, on the devices list in Poseidon. You see there's no ghost device anymore. But anyway, that mass storage was showing, but it never showed as an icon. And I plugged it in and out and tried reconfiguring it, and then I realized that I don't have the FAT95 file system installed in the Amiga OS, that most of my pen drives were formatted in FAT file system. The support for that was not installed in Amiga. I was assuming all the time that Amiga OS 3.2.2 already has built-in FAT support, but it doesn't. So you need to actually download it from the Aminet. The file is called FAT95, and just drop it right into the L drawer, and then you'll have all your icons and support for your FAT formatted pen drive. So okay, so there it is. Let's look at it in a little bit more detail. So if I double click into it, I have the device information. So look, it's connected to port 2 at USB 2.1 hub. This is the USB 2.1 hub. This is the port is number 2 here, and what's interesting is that actually it has an address. It has something to be connected to. It has a location to which it is connected. If we go and compare it to, let's say, the 2.1 hub, it will also have a location, port 3 at USB. So this one is connected to port 3 at this one of the root hubs. But if we go to the root hub, let's see, maybe this one, it's connected port 0 at nothing, because that's our top of the hierarchy or the bottom of the tree, however you represent it. So it's not connected to anything. It is the top of the hierarchy. So that's that. Now let's go again, double click into the our pen drive. That's the device again. It shows the power state, the power supply versus how much is drained. More on that power supply later. And it also shows the class that is assigned to it. All the pen drives will be assigned the mass storage class, and most of the pen drives will have just a single interface, as will have most of storage devices in general, just one interface. So if we double click into that interface, and if it's to its assigned class, we will see that you can configure the file systems depending on what is discovered on the device. By Poseidon, it will assign the appropriate file system to it. So again, you need to have that file system obviously installed in the Amiga, which I didn't do and which cost me a lot of frustration. You can also see how it's represented from the SCSI or SCSI abstraction layer. If you want to do something with the device, for example, formatted using HD Toolbox or whatever, then you see which unit it is and which device it is represented as in the Amiga. So it's USB SCSI device. USB SCSI device. So remember, if you then want to, for example, go to HD Toolbox, and do something with it, you would have to go and you would have to, in the tools, HD Toolbox, if you double click it, it scans USB SCSI device, and it found it. It's the unknown one. I want to exit it now, but if you want to do do anything with that device, you would have to always confirm whether in the tool type you have this device as the active one. So you need USB SCSI device. That's that. Okay, so now we see this, we have this one icon. How about we connect a few more? Click. You hear the sound? I'm not sure if the sound is heard, but whenever Poseidon discovers something, there's this notification layer that kicks in. So it gives some connection sound. It also sometimes pops up a message depending on how it's configured, and that requester that is popping up also giving you quite a few options to dismiss it or to keep it, etc. Let's see if it pops up for it, because I dismissed them already for some of the devices, maybe for all of them. Let's keep switching them on. You see how the icons appear one after another. We have already 3 of them. That's the 4th one. Sometimes they will return errors, especially if they are formatted in FAT. FAT is a finicky thing to work with. Sometimes it will return read errors or whatever. If I format them in Amiga, one of the Amiga native file system, it then works fine. That's another one. How many of them we have already? 6. They keep popping up, you see, as icons. I love it. I can already see that there is going to be some read error with one of them. The reason being that I see that it's slowed down. You see, this is the kind of problem, these are the kind of problems you may expect with USB on the Amiga. It's nothing to do with the Poseidon software. It works fine, but Amiga is trying to read one of those through the FAT file system, and it has problems with the pen drive. Pen drives, some of them are very cheap, and pen drives not always work nicely with Amiga. You need a good pen drive. You need to test it on your Amiga. It shouldn't be too big. It shouldn't be too cheap. These are often problematic. So test it out on yourself. Like, you will definitely find one at home that works with your computer, but you need to do some testing before you're happy with it. Definitely some of them are causing me problems and giving me those errors. Let me now quickly skip a few minutes because it will take a moment. All right, and now I think I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Where's the 10th? Maybe that was the one that was giving me trouble. Yeah, one of them is not working as expected. So I have 3, 6, 9 reported out of 10. That's fine. That's fine. Let's double click into shell and let's issue the info command. You see all of them nicely listed here. This is amazing because I have so many gigabytes at my disposal now across multiple file systems. Some of them are FAT formatted, some of them are not. You can move your files between multiple Amigas and other operating systems. So this is really, really cool, and it's all working. Of course, you need a powered hub for that to provide energy to all these pen drives, but that's a separate subject. I'll get to that in a moment. So here we are with pen drives. Now let's try other mass storage devices as well. So the first one is this Logilink USB to IDE and SATA interface. Let's switch this on. I think this is the port. See what happens. It's spinning on, and it shows as a mass storage ATAPI bridge, ATA ATAPI bridge. Very nice. It has 2 partitions which I created on this hard disk long time ago, Toshi 1 and Toshi 2 to represent Toshiba. And if we go to shell and do info, you'll see they are here. Actually, we can change to that disk. There is a file there. I can... No, there's no file, it's just trash can. What about the Toshi 2? No, I don't want to go to that. I want to go to Toshi 2 drive. Now, see what's there. There's nothing there either, just a trash can. That's fine. So that's a lovely way to add disks ad hoc to your Amiga system. With 3.2.2, without any special preparations, actually very large partitions can be supported. Yesterday when playing with that, I tested this, another Toshiba hard disk with 2 500 gigabyte partitions. So it's a total 1 terabyte, which is really sufficient for any of your Amiga needs, probably. Okay, let's actually connect this one. And I want to say a few words related to how we connect this disk. So you remember what I said, like we really need a lot of power for some devices, and I can see how important that is with a little experiment. So I'm gonna connect it not directly, but through amp meter here. All right. Okay, I think it's now showing what I wanted to show. So it shows 150 milliamps at idle. Okay, remember at idle. So what I'm gonna do now is try and copy a relatively large file, around 2 megs, to that hard disk, so that we observe what happens then. It goes up to 400 milliamps. So it went up by more than 2 times. These are still small values because the USB port here in this Spider card, I think it's rated at 500 milliamps, so it's still within the range of supported values. But we need to remember about these jumps of the current being drawn by devices. We may think that when we connect a few devices, it all works fine, and you know, okay, the power is all within limits. But then we start doing something with those devices, the power draw jumps up, and suddenly, you know, there's a freeze of the system. Some things slow down, some things disconnect. What's happening? Well, the reason being that sometimes there's not enough power. So I highly encourage using external hubs, external powered hubs, and also they need to be of good quality. The power supply for this one is 60 watts. It's a large power supply for seemingly large for a hub. But this works very reliably, and I prefer connecting to this externally powered hub, then drawing all that power through the power supply here, through the mediator, through the PCI bus, through the card. It just seems less reliable that way, and seems more reliable using the external hub. So the copying finished. It's back at 150 milliamps. So that's one of the things that I wanted to illustrate. But now, okay, we have all those icons here: Toshi 1, Toshi 2, Big Toshi 2, Big Toshi 1. They are all connected here to mass storage devices. That's great. To wrap up the mass storage device topic, there are 2 more devices that I want to show. One is the CD and DVD reader. The other one is floppy drive. And let's try, and they are actually already connected. Let me see how they are represented in Poseidon. Actually, let's go to the shell first, and let's restart the Poseidon just for fun. PSD restart, that's one of the commands that I often use when something is not working right. The Poseidon stack acts up, or there are devices stuck in a weird state. This is a very good command to use. PSD restart. Look what's going on. There are all those notifications about disconnected and then reconnected devices, because this is what's happening. They are disconnected, the whole stack is restarted, and then reconnected again. Those notifications again can be disabled, but they are very helpful. I keep them on just to know when something is connected, disconnected. Sometimes I do that inadvertently, connect or disconnect something, so it's good to know. Again, we restarted the stack. Let's look at the representation of these devices. So here is the mass storage CD DVD. I think the floppy drive will not register until I put floppy in it, but let's first start with the CD drive. So let me get one of the Amiga Future discs, pop it in here. Let's see what happens. Should be starting. Let's close this and close this. It takes a few seconds. There it is, Amiga Future, nicely through the USB port, so you can open your CDs, you can open something in it, whatever iBrowse browser. You can open a README just to see that it opens from the CD through USB. Nice. Okay, let's close that off. If I take it out, the icon will disappear as expected. So the USB drive doesn't differ really from any other drive, except that it uses the CDFS system in the L drawer. You need to remember to have that file system there so that it's properly supported. And now also let's pop in a floppy to the floppy drive. Remember, this is a PC compatible floppy drive. It's not an Amiga floppy drive. There are no USB floppy compatible Amigas from what I know, but we can read old PC floppies, which is convenient in itself. Let's see. Okay, I actually had to restart Poseidon once again, but ultimately the floppy disk popped up. You see, this is an example where sometimes things don't work as smooth as expected. I'm gonna talk about the reliability of USB in Amiga at the end of this video, but this is just an example where you need to manually restart the Poseidon stack to see something. It happens. Not a big deal. Info. So we see that's our diagnostics disk. This is again a PC floppy inserted into a USB floppy drive. Let's go and see what's there. A lot of execs and bats and sys. I think it's some kind of bootable floppy to diagnose stuff. Good. Let's pull that out. And let's move on to HID devices. HID stands for Human Interface Device, and it's mostly mice and keyboards, and also a few tablets, touch screens, anything that enables you to interact with your machine. So let's go right into it and plug this mouse in. What happens immediately? A pop-up, USB optical mouse, and the most interesting thing, it's ready to use. Like you plug it in, it's there. Chris Hodges spent a lot of time to perfect the HID class of devices, and he also contributed changes to the input device. The original input device on Amiga didn't well support multiple devices. Now it supports them very well, and you can actually use any mouse that you have, and I could plug 5 more and they would be still working. But that's not the only interesting things. You can actually go to Trident now, but before we do anything else, let's take a quick look at the error log. I forgot to mention about it. Poseidon has a very interesting message, informational and error log here below. You can also read it through the command line using the psd error log command. It's an interesting educational read, and also pretty funny because Chris Hodges has a wicked sense of humor and adds a lot of commentary to otherwise boring error messages or information messages. For example, Poseidon library Popo kicks ass. I don't know what it is, but or device USCO2 says it's currently self-powered. Fixing config. Okay, that's normal. But how about play it again, UCO2, or hit the road, HID, hit the road, UCO2, etc., etc. Sorry, digression. We connected the mouse, and it's here under HID class, USB optical mouse. Speed low, so it uses the 1.1 12 megabit speed because it doesn't need anything faster. HID devices don't need fast connection. Let's click to it. It has 2 interfaces. You see there are 2 interfaces, HID mouse and HID. And let's click into the first one and let's see what's available here. So if we go to action, what we see is we can reconfigure the buttons just using the HID class written by Mr. Hodges. So that's very, very interesting. So you don't need to use any preferences in your Amiga OS. You can do it right from within Poseidon. So let's try and reconfigure one of the buttons. So the very helpful option here to do that is you click track incoming events. So see, when I move the mouse, it's already two different events switching between one another, X and Y. Now if I click the right button, it's very difficult to do that without moving your mouse. Yeah, that's secondary button, did you see? Now if I click the left one, that's primary button. And now we'll try to figure out which buttons are these. This is the fourth, you see? This is the fifth. Where's the third? Where's the third? The third is, I think, in the middle. Yeah, that's the one. Did you see? Yeah. And then there's a wheel. Wheel is already there. Okay. So now let's try and assign some action to buttons 4 and 5. And I would like them to bring a window to the front or to the back, because that's what I always struggle with in my Amiga OS. So let's create a new action. Let's stop tracking. We already know which buttons we want. Here, new one. It has no action, so again we want miscellaneous. Miscellaneous window to back. And important stuff, we want it on the key up, so not just when we press, but we press and release. That's an important one. There are many people confused why, for example, links don't work in eyebrows for them properly, because they didn't select the up action. The up action should be for the click, not the down. You don't only click, but you click and release. That's the behavior that we're after here. Okay. Let's see if that works. Now, hold on, one more. Button 5, new action, miscellaneous, window to front. Okay, and they should start working immediately. So let's grab some window. Is that going to take it to the back? Yes. And is that going to take it to the front? Yes, it's working. I'm gonna save it. I love it. Okay. And we can continue using it. I may actually end up just keeping this mouse because I really like its ergonomics. Okay, that's cool. What else? That's that about HID devices. Of course, you can configure a keyboard in a similar way. It's not always that easy. So I was planning to leave that for later for the section about tricky devices, but this one gave me trouble. I was unable to configure these buttons, and it should be possible via the Poseidon interface. I'm gonna try a different keyboard from this one to see if that's possible. But in any case, let's move on to more challenging devices, ones that I had some struggles with, just to show that not everything is perfect. Let me bring a bit heavier device. Now, don't you worry, I'm not going to play this instrument. The reason being, I don't know how to play, but that doesn't matter. I use it for illustration purposes. We have this instrument in our family because we just enjoy pressing random keys and listening to the sounds of them. With my daughter and my son, the daughters and my son, we love this exercise. But let's see what's so challenging about it for the purposes of our video. So when I switch it on, it's detected. You've heard the sound. Let's look into Trident devices. So there it is. It's an audio device. It's recognized correctly as Swissonic 88. It has 88 keys, but I had to manually assign simple MIDI class to it, because when with its default assigned class, which was for this MIDI interface, it was this one, CAMD USB MIDI class. When I used this one, I couldn't get anything out of this device. So my plan was to connect it to Octamed and just play something there, but with the default class it just wouldn't work. But the default class is needed to support the full functionality of it. It's not only key presses here, but there's volume control, there's switches of instruments, there's slides and all kinds of effects. So again, with the default class I couldn't get that, so I had to manually switch it to simple MIDI class, which you do like that. You just right press the interface and you select the class that you want to bind to this this interface. So in this example, that was simple MIDI. It asks for confirmation. Yes, I'm not dumb, I know what I'm doing. So I have assigned it, can close it and use it. And only now was I able to actually get anything out of this. So if I select an instrument in Octamed, let's load an instrument. All right, it works. It works, but again, it only works by passing the key codes to Octamed. Actually, not Octamed, to any app. So basically, if I quit Octamed and let's even open shell, it still passes some characters there. That's not how it's supposed to work. The expected behavior is that all the volume controls work, and it actually is able to receive MIDI signals as well and pass them on, and like all the percussion keys work, switching of instruments, etc., etc. But anyway, it's better than nothing. So that's one of the challenging devices. Another one is another USB audio device. This one, and it's challenging for a couple of reasons. So if I connect it, it's recognized. Pop-ups actually recognizes two devices. That's interesting. And that's one of the challenging bits about it. So if you look into Trident, go to devices. This is our device UNC202HD, and we look at the details. It has like a dozen of interfaces, So probably this is expected, but the challenge was that I wasn't able to bind any of these interfaces to the ACI sound driver. I don't know, probably I missed something, or probably I haven't read the documentation for the audio class correctly, or for the ACI drivers, but I couldn't get it to work. Another challenge, or maybe a curiosity about it, you remember how I said that Chris Hodges mentioned that theoretically USB device can support more than one configuration, but he hadn't been able to identify any device that has more than two configurations. Here, like, I can clearly see two configs for this device. That's the only device out of the ones that I tried that actually shows two config, but they are numbered in the same way. There's config 1 and config 1. So either there's a bug in this Poseidon software in how it interprets the configs, or this device is misconfigured, or I don't know what. But anyway, I'll keep trying because I love this USB audio interface, and I was trying to get record samples directly into Amiga. More challenging devices. Here are a few. Let's switch this off so that we have better clarity. This is a wireless LAN interface. It's recognized correctly as a device, but then you see this little red vendor icon. It's running, it's recognized by Poseidon, but it doesn't have the drivers. They were just not written for this device. So that's the challenge. You can't use it unless someone at some point, maybe in future, writes a driver for the Amiga for this device. Another one. Again, it's a USB ASP. I griff. I think this is a programmer for controllers. I forgot what it was actually, but anyway, that's also vendor specific driver that's needed there. Another one, this is a GPS receiver. It works lovely in my Linux laptop, and it's recognized as a USB to UART controller, bridge controller, and probably running as expected. But again, you need some kind of drivers to get the GPS functionality. Actually, I haven't searched in the Aminet. Maybe there's something. I'll try and look up something there, and I'll update my article. By the way, everything I'm talking about here will be documented in an article that will be linked under the video. Take a look at that, because the article will be updated. The video will be not, when I find some new information. And the last one is this dongle, which is another USB to serial controller. And again, you see it's vendor specific driver, but actually this one is recognized as serial P12303, so I probably would be able to connect something and get something out of it. So maybe it's not that challenging, it just needs some work from me. Hold on, what was the GPS showing on the class side? Maybe it was also showing something that I didn't notice before. Okay, I see what's happening. So you remember I said that the binding to a class may happen either at device or interface level. So this is bound here on the device level to serial CP210X class, versus on the interface, which I understand represents the connection to the GPS receiver itself. It's not bound to anything, and it's driver, and it's vendor specific. Anyway, I think that's that. There are tons of USB devices in every home, so you can try your luck with other devices. You can read the Poseidon documentation. If you're a programmer, maybe you can attempt writing a driver for a device that doesn't have a driver for the Amiga yet. Please comment, let me know what you've found out, or maybe where I've made a mistake in some of my assumptions. I'd love to learn. I'll update all that information in the article, as I mentioned. But for now, I think that's that. It was fun learning about all that, and talk to you next time.